All right, welcome. So here we are. We finally get to the point of solving problems with the assistance of a cubed minus b cubed and a cubed plus b cubed. This is the difference of perfect cubes, okay? So we know that a squared minus b squared is equal to this. A squared plus b squared is not factorable, and we showed in the last video that a cubed minus b cubed is this whole thing, and a cubed plus b cubed is this whole thing. So how can we actually use this, okay? For example, let's look at this. If we have x squared minus 25, and we wanted to factor this guy, right? Easy peasy, right? Easy peasy. What do we say? It's just simply, wait, let me get my nice pen. Okay, so we just simply say that it is x minus 5 and x plus 5, okay? That's just what it is, right? But remember, I know this is being, what we're going to do is we're going to break this problem down, because the way we break this problem down will be the same way we're going to break this problem down. And if you're thinking, Mister, I know it's x minus 5, x plus 5, you're right, it is the answer, but that's not the point, okay? The way we get this answer will help us understand all this. It is understanding what these a's and b's are, okay? So remember, this x squared minus 25 is in what format? It's in that a squared minus b squared format, right? But how is it in that format? See, how? Why? Okay, these two questions you're thinking, Mister, you're being extra, you'll see that it'll be very helpful. Notice that x squared, this is some perfect square, right? 25 is a perfect square. So remember, this x squared has to look like what? It has to look like that a squared, right? X squared has to look like that. I'm sorry, x squared has to look like that a squared. So if a squared, let's see, if a squared is equal to x squared, right? What does a equal? It equals x, right? And if b squared, right? If b squared is equal to 25, b is equal to 5. And then how did we go from this step to this step? Well, you know, you just take the square root, right? You take the square root, you take the square root, you take the square root. Square root of a squared is a, square root of x squared is x, square root of b squared is b, square root of 25 is 5. And you're thinking, Mister, for the love of God, I know this. And you're right, you do know this. But remember that, you see, this a squared minus b squared. Let's just substitute a for x and b for 5. Okay, that's all we're gonna do. So anywhere you see a, you're gonna put in x, and anywhere you see b, you're gonna put in 5. So what does this become? Let's get a nice pen over here. So you see a squared. Well, a squared is equal to x, right, squared minus 5 squared, 5 squared, okay, we're going to put parentheses squared, is equal to, now remember this is a, what's a? A is x, minus b, which is 5, times x plus 5, okay? And notice the reason why I had it like this and not like this, you see I didn't square it yet, because once you put everything in and just solve it, this x to the second becomes x to the second, that 5 to the second becomes 25, and then notice that everything is satisfied, right? Everything is satisfied. Okay. Now how does this help us understand what this is? And I will show you. Okay, so now we have x cubed minus 27. Notice, we're not dealing with the squares, right? If we wanted to use a squared minus b squared for this one, can we? Absolutely not. You know, square root of x, you can't take the square root of this, right? You can't take the square root of 27. These are not perfect squares, but they are perfect cubes, okay? And just for a little heads up, what is, because here, you know, the perfect squares, you know, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 1, 4, 9, 16, 25, 36, blah, 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 blah. We all know that. But what are the perfect cubes, right? What is 1 cubed? What is 2 cubed? What is 3 cubed? What is 4 cubed? What is 5 cubed? What is 6 cubed? Okay? Try and do this in your head. And what are they? Let's see. 1 times 1 times 1 is 1. This is 8. This is 27. This is 64. This is 125. 6 cubed. What is 6 cubed? What is it? 216? Okay. So these are the perfect cubes, and they just keep going on. So remember, if we see perfect cubes, these are big happy face, right? Because if we had happy face for doing perfect squares, now we want happy face for perfect cubes, okay? So here, 27 is a perfect cube. But what about x cubed? Why is this a perfect cube? Let's see. If we try to do square root of x squared, what do we get? I'm sorry, if we try and do the square root of x squared, that is x, right? But what if we try to take the square root of x cubed? That you cannot do that, because what number times itself gives you x cubed? It won't be a very friendly number. I'll teach you how to do it, but for now, this does not work. So then, what are we going to be doing here? We're going to take the cubic root. Cubic root. You see here, how do you pronounce this? This is square root, right? This is square root. There's a 2 here. Here, we're going to take cubic root. So you see here, if I take the square root of 25, I ask what number times itself gives me 25. That is 5 times 5. What is the rhythm if I say the cubic root of 27? What number times itself 3 times gives us 27? It will be 3. Because 3 times 3 times 3 is 27, right? What if I take the cubic root of, I don't know, 125, right? If I take cubic root of that 125, what is the cubic root of 125? That is equal to 5. That's equal to 5. Why? Because 5 times 5 times 5 gives us 125. So here, we could take the cubic root of x. We could take the cubic root of x cubed. Sorry, take the cubic root of x cubed. Oops, my bad. Why can we do that? Because what is the cubic root of x cubed? It's just x. What number times itself 3 times gives me x cubed? It's going to be x, because x times x times x equals x cubed. Okay? So now, we're running out of space, so what I'll do is I'll just put it over here on this one. Right? So x cubed minus 27. So how do we get that into this format of a minus b times a squared plus ab plus b squared, right? How are we going to get, how do we factor this into something that looks like this? Because we learned in the last video that a cubed minus b cubed, if you factor this, it equals this. So now we're going to try and factor this to look like that, okay? And this is why I talked about here about finding what the a's and the b's are. Because you could take those a's and b's and substitute it into here. And that's what you're going to do here. You're going to find the a's and b's of this and substitute it into that. Okay, so then how do we do that? Well, here, what can we do? We can take the cubic root of x cubed. We can take the cubic root of 27. And if you ask yourself, why can we do this? They are perfect cubes. You have to start realizing that x cubed, you could take the perfect cube of that. 27, you could take the perfect cube of that. I'm sorry, you can take the cubic root of that. Here, you can take the cubic root of all these numbers, okay? So what is the cubic root of x cubed? That will be x. So we know, okay, that will be x. But all right, let's see. Remember, if we have, I got you guys. So a cubed minus b cubed. Here, and the problem is x cubed minus 27. So here, let's actually solve it right now. We want this format. We want to see what the a and what the a will be here. So here, if a cubed is equal to x cubed. And what is b cubed here? B cubed is 27, right? How do you figure out what a is? How do you figure out what b is? Before, here, a squared was x squared. And what did we do? We took the square root. Here, b squared and 25, how did we get b by itself? We took the square root. Here, you will simply just take the cubic root. Here, just take the cubic root of a cubed. Here, you take the cubic root of x. Here, you take the cubic root of b. Here, you take the cubic root of 27, right? So what is the cubic root of a cubed? That's a. What's the cubic root of x cubed? That's x. What's the cubic root of b cubed? Is b. What's the cubic root of 27? Is 3. So now I know a is equal to, I know a is equal to x and b is equal to 3. And now, great, I have a formula for this. We can substitute this into the formula. So just substitute. What is a? It's x. What is b? It's 3, so it's minus 3. And now here, what is a squared? If a is equal to x, what is a squared? A squared is equal to x squared, right? So this is just x squared here. Now this is a times b. What's a times b? It's just plus 3x. And what's b squared? That's just plus 9. And that's it. You did it. That is it. This whole, I'll just write it again, x cubed minus 27 is equal to x minus 3, this binomial times this trinomial plus 3x plus 9. And that is it. That is all she wrote. Very good. That is it. That is all you do. This one, you have x cubed minus 64. Okay? You can do this. What would this be? Try and figure it out on your own, and then we'll go over the solution. Okay? The other question, what is it? 2x cubed plus 128. Right? Try and solve it on your own. And notice for this question here, a little hint, 2 is not a perfect cube. 128 is not a perfect cube. Hint, what is always first move? If you can, take out what? Take out GCF. Or what did Joseph Aponte say? If possible, take out GCF. Okay, take out GCF. All right, so let's see the solution for this one. Here, if I know a cubed is equal to x cubed, and if I know b cubed is equal to 64, because this is in what format? It's in that a cubed minus b cubed format. Then I know a is equal to x, and I know b is equal to 4. Right? Because you take the cubic root of all that. And then you simply do what? You just take the a and the b and put it into what formula? Oh God, where is it? You just put it into this formula because we're using an a minus b cubed. Okay. Hold on, I have to sneeze. Okay, can't sneeze. All right, so yeah, I know a is equal to x and b is equal to 4, right? This is how you should be setting up this problem. And now you just plug it in. So it is, what's the formula again? It's a minus b times a squared plus ab plus b squared. And that is equal to, you just substitute it in. You get x minus 4. And then what does this become? X squared plus 4x plus 16. And that's it. That is it. That is happy face. We're done. So we know that x cubed minus 64 is equal to this. And you start developing like a pattern, right? Isn't there some sort of pattern you see? Yeah, for this one. There is some sort of pattern. You see, it's an x and an x, a minus 3, the x squared. Remember, this is you know, it's this middle term squared. It's that middle 4, you know, it's squared. But okay, anyway, you start developing these patterns. Let's look at 2x cubed plus 128. You factor out the 2, and you get x cubed plus 64. And then notice that this x cubed plus 64 is in what format? It's not in a cubed minus b cubed. It's in a cubed plus b cubed. And this is factorable, right? We have a formula for this. It'll be this guy. But what is the difference between a cubed minus b cubed and a cubed plus b cubed? It's not that bad. And in the class, I'll show you, remind me, Mr. G, what is SOAP? I know you're thinking I'm crazy, but this acronym will help us memorize this formula. And it's really not that bad. Okay, so let's go back to the problem. We have 2x, 2 times this. And now this, we factored out, but this is equal to what? We already know, you should know by now, not by now, but if a cubed is equal to x cubed, let's see, b cubed is equal to 64, then a is equal to x and b is equal to 4. So I could just substitute that into the a cubed plus b cubed formula, which is a plus b times a squared plus ab, I'm sorry, not plus, minus ab plus b squared, right? You just substitute it in. So then you know that x cubed plus 64 is equal to x plus 4 times 16 minus 4x, I'm sorry, not minus 16, I'm sorry, x squared minus 4x plus 16, right? And that's what this is. But remember, the original problem is here. It's 2 times whatever this factored form is, right? And this factored form is this guy here. So the final answer will just be 2x cubed plus 128, that's the original problem, is equal to 2 times, right? 2 times this factored form. So that's just x plus 4 times x squared minus 4x plus 16, right? And that is it. That is it. Not too bad, right? What I'd like you to do is, where's that paper? Ah, yeah, over. Let's zoom out a little bit. Hopefully I get this right. Oh, I zoomed out correctly. All right. So that was these 3 questions. And now, try and do some of these questions in the back. Now you see here, what was the game plan of this lesson? It is mastering factoring, okay? These questions over here are a little more difficult, okay? You do not know which technique to use. You do not know, but you got to figure it out. I'm sorry, not that you don't know. They don't tell you which technique to use. You have to figure it out, okay? These are the techniques. And what I'd like you to do is, at the very end, these are very nice. Can you create, this question is saying, can you create expressions that have a structure of difference of squares, difference of cubes, sum of cubes, right? Remember, this x cubed, oops, what am I doing? Oh, did you see that at all? Yeah, this question. But this is, how do you read this? This is sum of cubes. This is difference of cubes. No, that's this format. Oh no, wait, whoops. Yeah, no, that's good. Okay, all right, enjoy. I'll see you in class.